Hi guys, welcome back and once again to Water Process and Engineering Services to our video blog. It's been a long time that I made a video, and this time I'm going to share you another video blog. Our topic for today is why is it that this fiber reinforced plastic will be deformed, or there's an incident that this FRP fiber reinforced plastic will deform by its shape. So today I'm going to talk about what is the cause of the FRP to deform. Okay, so what are the preventive measures to be done to avoid the deformation of the fiber reinforced plastic? Okay, in this video I'm going to show you what is the cost. So let's say, for instance, this 30 ml bottle plastic or PET bottles is the FRP. So I'm going to show you what is the cost of the fiber reinforced plastic to deform because of the vacuum of water, or the air pressure, or the vacuum of the vacuum of the air pressure. So if this let's set as an example that this bottle is the fiber reinforced plastic. So this bottle is empty, as you can see. This is empty, and we have one glass of water to fill. So by the way guys, these are the details of the fiber reinforced plastics. We have the maximum pressure of thin bar equivalent to 150 psi. Maximum temperature is 49 degrees Celsius or 120 degrees Fahrenheit. Minimum temperature is 1 degree Celsius, 34 degrees Fahrenheit. Maximum vacuum 127 millimeter, and do not exceed specifications. So this is size is 10 by 54. So that's it. This is the details of the capacity of this fiber reinforced plastic. So our video will talk about what is the cost of the fiber reinforced plastic to deform. So a lot of our customers came to our shop to talk about the problems of deformation of the fiber reinforced plastics. If mostly the size of the fiber reinforced plastic is 10 by 54, just like this one, and also we have the 13 by 54. So they talk about the deformation. They had the problem of deformation of the fiber reinforced plastic. So what is the cause of that incident? So if this row pump will suction, well, this is the intake portion, and this is the output. So once the row pump will suction water from the row tank or any source of container, if it happens that this row pump cannot suction any fluid, or did not suction any fluid, so it suction only air. So what happens if this FRP, this is the pipeline of the intake and this is the output, and what the fluid or the water will goes down, will enter to this FRP tank, goes inside to this fiber reinforced plastic. And there's also the this one. There's also the reverse osmosis pump that will suction the water, which is feed by this row pump. So there's a combination of suction feeding and the suction of the reverse osmosis pump, which is that one. So once this row pump will feed water from the row tank, so basically the water goes down with this fiber reinforced plastic. Then the reverse osmosis pump will also suction water from this pipeline. This is the feed water given by the row tank, and this is the output. So once the water from this FRP tank will be suctioned, if there's a water that is inside in this row tank, and also the reverse osmosis pump will suction water, well, there's no problem if there is a water. But if happens that when the reverse osmosis pump cannot suction, or there's no water that being suctioned by the reverse osmosis pump, there's a big problem with that. That will happen. The problem with that one is this FRP tank will be deformed. So this will become, since this is a cylindrical, this will be deformed, because what is being sucked is only the air. So the air pressure from this FRP tank. Once that will happen, if this row tank will have no water to feed in this FRP tank. So I will explain to you in another way so that you can understand what I mean. So let's say, for example, that this is the fiber reinforced plastic. This is a 330 ml fiber reinforced plastic, and I'm going to suction this one by using my my mouth. Okay, so let's see if what happens to this fiber reinforced this pit bottle, should I say. You just shoot this pit bottles. Okay, I'm going to demonstrate. So this is empty now. So supposing that there's no water, so this supposing that there's no water that is inside of this pit bottle, and let's set this one as an example of the fiber reinforced plastic. So let's try to see what happened to this one. I'm going to suction this one. I will use my mouth as a suction pump. Okay, try to see if what happens. See? Did you see that one? So that means that if the fiber reinforced plastic is being sucked without water, that the thing that you see is what happened to this fiber reinforced plastic. Okay, let's do it again. So I'm using my mouth to suction sample of suction pump. See? So that's what happened. Then I will give you an example that I will pour a water to this one. So there's a water that is being that is inside. Okay, just focus first that one, and I will pour water. Okay, like test again what this is. Water process and engineering services, trying to demonstrate you what happened if the fiber reinforced plastic is being deformed. Okay, let's try to see this one. This PET bottles is let's just set as an example of the fiber reinforced plastic. Okay, I will demonstrate right now. That this fiber reinforced plastic is filled with water. So I'm going to suction again using my mouth, and let's see if this fiber reinforced plastic, oh, the PET bottle should I say, will deform. Okay, try to see it. Okay. Try to okay, let's try it once again. Okay, see, this is has a big difference if there's no water that is inside this fiber reinforced plastic. So the PET bottles did not deform completely because there's a water that is inside this fiber reinforced plastic supposed to be, but we're just using for this PET bottles. Okay, see, I'm going to demonstrate once again. See, it did deform, but it bounced back because there's a water that is inside, not like with the empty container, empty PET bottles. So that's it. That's basically the an example of what happens if your fiber reinforced plastic, this 3 fiber reinforced plastic, cannot suction water. If there's no water, should I say, if there's no water that is being fed by this row pump. So that is basically what happens to your fiber reinforced plastic. It will deform, and worst comes to worst, there's after deforming, it will produce a crack and even leak. So that's it right here on water process. Another tip, another information all about water refilling machines. Right, thanks for watching the video right here on water process and engineering services. Okay, so once again I'm going to demonstrate. I'm going to pour this wine water on this. Okay, and once again I'm going to demonstrate what happened to this fiber reinforced plastic if there's no water that is being suctioned. Okay, once again I'm going to show you so what happened to your FRP if there's no water that is being feed to this fiber reinforced plastic. This is what happened. Okay, that's it right here on Water Process and Engineering Services. Once again, so that's it. That thing that will happen to your FRP. See? You can see the deformation of it's simply something like that will happen to your fiber reinforced plastic. It may be 13 by 54, 10 by 54, and 16 by 65, and other sizes. That's it right here on Water Process and Engineering Services. Tells you about what is the cause of the deformation of your fiber reinforced plastics. Right, thanks for watching the video. Please like and subscribe to our channel for more information, for more notifications of our upcoming videos. Thanks again for watching the video. This is Water Process and Engineering Services.